Hello everyone, my name is Oxozo and this is my English video presentation for algorithm. So today I will talk about algorithm design techniques and which are very important in computer science and software development. Also, algorithms are not used only in programming, but in real life it's also used uh, whenever we follow step to solve a problem, we are actually using an algorithm. For example, cooking a recipe, planning a trip, or managing time during exams are all real-life algorithms. So in computer science, algorithms help us solve problems faster, cheaper, and more efficiently. So in this presentation, I will explain five major algorithm techniques, and I will explain the idea, given the real life example, and I will also show the practical demonstration so that the concepts are easy to understand. So the topics are, as you can see here, divide and conquer, greedy algorithm, dynamic programming, correct algorithms, and NP completeness. Okay, let's begin with an overview. So, okay, this is our overview or outline. So these five algorithm techniques are used to solve different types of problems. There's no single algorithm that can solve all problems efficiently. So that is why computer scientists study many algorithms strategy. Some problems are very large, so we have to break them in smaller parts, and some require fast decision, even if the solution is not perfect. And also some problems require optimization when we want to the best possible result. And other problem involve connection, roads, or networks. And finally, some problems are extremely hard, even for the powerful computers. So I think each technique that I will explain today is designed for one of these situations. Okay, so next one. Okay, the first one is divide and conquer. So divide and conquer means it's breaking a big problem into smaller parts, solving each one by one, then combining the results. This idea is very natural for humans. Let me give a real life example. Imagine you're studying for final exam, and you don't study all subjects at the same time, right? Instead, you divide your study into subjects, then into chapters, and then into small topics. So you study each topic one by one, and finally you will understand the whole subject. So that is exactly how divide and conquer works. So in computer science, this approach reduce complexity and also make problem manageable. So it's a divide, solve, and combine. Okay, let's go to the practical one. So now I will demonstrate divide and conquer using binary search. Okay, so binary search is used to find an element in a sorted list. First, you can see this array. So I'll look at the middle element. So in this example, the middle one is 6. But as you can see, our target is 8. So if I compare with my target value, which is 8 with 6, 8 is greater than 6. So I know the value cannot be on the left side, right? So we have to check on the right side. So now I focus only on the right half and I can see 8, 10, 12. Again, I check the middle element, which is 8. So then I found the targets. So instead reduce the problem size by half. So for the real example, it's like looking for a name is a phone corner list. You scroll like to the middle and not from the first corner. Maybe you can divide that corner in everyday life. Also, you can find a word in dictionary the same. Okay, and then we go to another one. So the next one is the greedy algorithm. So a greedy algorithm makes the best choice at the current step. without thinking about the future. And humans use greedy algorithms all the time. Like for example, one choosing the faster route to class because you're late. So you do not check all possible route. You choose the one that looks faster at that moment. So that is a greedy decision. Now let me demonstrate with a coin chain problem. So suppose I want to make 20,000 using the pure coin, as you can see here. And like the greedy approach is to choose the larger coin first. So I choose 10,000 first, and then 5,000, 2,000, 1,000, etc., etc. So I repeat the process until the remaining amount becomes zero. So this approach is very fast and easy to understand. What about greedy algorithms are not always optimal. Sometimes it can block a better future solution. So that is why we must understand the problem before using the greedy algorithm. Okay. Okay. Then okay. Now let's go to the dynamic programming. So which one the most important algorithm technique? Also, the binary programming is used when the problem is overlapping subproblems. Instead of solving the same problem again and again, we store the reset and reuse this. For the real life example, if remembering answer for repeated question. So if someone asks you the same question many times, you do not think again. You just say, oh, this is the answer, something like that. So you remember the answer and reply immediately. There's no without hesitation. So that is dynamic programming in real life. For now, let me demonstrate this using the final Fibonacci sequence. So without dynamic programming, Fibonacci numbers are calculated repeatedly. But with dynamic programming, I store each Fibonacci base for once. Whatever I need again, and I reuse it. So and then this save times and improve efficiency of algorithm. Okay. Then well, we'll go to the grid algorithm. So a grid is made up of nodes and edge. Also, grids are used to represent the relationships. A very common real-life example is Google Maps. So the cities are nodes, and also the roads are edge. And also the another example for real-life is social media. People are nodes, and the branches are edge. So graph algorithm always help us to analyze this connection and find ultimate paths. Okay. Then now, sorry, no, this one. Understood. Oh, sorry, this one. Yeah, this. Now I will demonstrate the breakfast search BFS. Uh, is explore a graph level by level. As you can see in here, if I start from the node A first, I will visit A, and now I'll visit to B and C. And then after that, I'll visit to the next level of D and E. So the BFS order is A, B, C, D, E. A real is a map of BFS is finding the shortest number of best stop between two locations. So BFS ensure the minimum number of steps. Okay, then we'll move to another one. So this is the final one. So finally, I will explain MP completeness. So which is one of the most challenging topics in computer science. So uh, this kind of problems are problems that's very difficult to solve, but also it's easy to verify once a solution is given. So a famous example is the traveling salesman problem. Okay, for the goal is to visit other cities exactly once. I mean, not twice, only one time, and return to the study city using the shortest time, shorter route. So, if I go level full city, as you can see here, A, B, C, D, there's already many possible routes. So, as the number of cities increase, the number of route grow extremely fast, right? For the real example, is like delivering companies. They do not calculate all possible route, right? Instead, they use approximation algorithms to get a good solution quickly. So this shows why NP completeness is important in practice. Okay, so as you can see in here, A, B, C, D, E, something like that. Okay, then let's go to the conclusion. So in conclusion, we already see different algorithm design techniques, and they use for different type of problem. So for divide and conquer, it helps us to break large problems into smaller ones. For the greedy algorithm, it helps us make fast decision. Also, dynamic programming avoids repeated work and is improve efficiently and save time. And also, gray algorithm is trying to help to solve network-based problem, and the last one, NP completeness, helps us understand the limits or maybe computation about computer. Okay, so understanding these techniques is really help us become a better problem solver and better programmer in the future. So my name is Osozon, and my student ID is 2024000295. So thank you very much for watching. Bye.